I'm not sure what level he wants it to be at. Um,
Okay.
I think he said go with one that you're confident with.
Okay.
So I don't know. Let me share my screen actually,
Okay.
and then so I just uh went with easy. That should be pretty good. Or actually, you know, I feel like a medium one might be enough challenge, and then also, wow, there's so many easy ones. Can we just
I think you can just pick an easy one that's high on frequency.
All right, construct the rectangle. Let's do this one. Rectangles are easy, right? Okay, a web developer needs to know how to design a web page's size. So, given a specific rectangular web page's area, your job by now is to design a rectangular web page whose length L and width W satisfy the following requirements. The area of the rectangular web page you design must equal to the given target area. The width W should not be larger than the length L, which means length is greater than width. The difference between length and width should be as small as possible. Wait, that means it's a square or almost a square, right?
Yeah. Yeah.
Okay, so areas for output is 2 and 2. Okay, so the smallest, all the possible ways to construct it are 1, 4, 2, 2, and 4, 1. But according to the requirement 2, okay, so this one is illegal. According to requirement 3, this one is not optimal compared to this one. So the length L is 2 and the width W is 2. Huh. And so we have the given constraints that area is less than 10 to the 7th.
Yeah.
This actually seems
Pretty hard.
pretty hard.
Yeah. Pick a
Obviously,
different one.
obviously, the brute force. Well, I'm assuming that they must be integers when they're returned. They can't be like a
Yes.
partial value. So like,
Yeah. It should be should be an array of integer.
yeah. Um, which means that like, hmm, if you if you went ahead and found numbers that it's divisible by, mm, I think okay for the brute force solution, right? It's
Yeah.
to iterate through all the numbers less than or equal to half of the given number, right?
Okay.
And then divide the number by it. And then if you get an integer back, and if the distance, the, so, okay, brute force solution is start at a number. I'm just gonna write this out. Start at half or less than if it's odd number. Because that'll give us numbers that are more optimum first. So if when we start iterating and we have a number, right? We first divide the area by it.
Wait, are you missing the underline between the word star half?
Huh?
It should be star half.
Start at half.
It's not. Yeah, you're writing a solo code, right? Okay, all right.
Or less than if it's an odd number. And then what we would do is we would take the area and we would divide it by whatever number our iteration's on. So we can just label it divisor, I guess. If I could spell. Area divided by divisor. And then we would get, if that's an integer, then we found the most optimum solution. As long as, yeah, we found the most optimum solution, then we just need to figure out which one is larger. And then reverse them if the divisor is larger, then we can just list the divisor and the number that we got back, the quotient. And if the quotient is larger, then we just switch them and we return the quotient and the divisor, because they need it in largest first and smallest.
Yeah.
So I think that if we take the area and we integer divided by 2, right? That should give us the largest, the largest one under half, or half. And then if we should assign that to divisor. And then while divisor, I spelled that wrong.
Yeah, I.
Is not equal to 0, right? Then we can iterate backwards. And then if area divided by divisor, right, without integer division, if that equals, I'm just gonna do this very simply and just, I think if we cast it to an int, right? No, wait, we could just do integer division. That's just to check if it's an integer. Like if it's not a float. That could be said better. that should I'm not too familiar with how to do that in Python because I don't often do type checks, but I think that's the syntax. Um, and then if it's not a float, and then we found we found a solution, then we should return divisor area divided by, I should probably set this to a variable. It doesn't give you like an alternative, like there's no possible solution. Well, I guess there's always a possible solution because you always have the number in one.
Yeah, it has to be divisor of that original number. It has to be divisible by the original number.
Yeah. Okay, and then all we have to do is divisor minus equal 1. Okay, I believe that this solution will work. I don't know how fast it will be, and of course there's always a chance I made a typo somewhere. Oh, that's no good.
The output, it's empty. Right.
Okay, so it doesn't,
It doesn't tell you.
I don't know if I didn't return something, because like this might be the issue right here. If the type is not equal to, if type equals int, maybe. Okay. I just want to know if this is being triggered because I think this if statement is what's causing the issue.
Nice.
Okay.
Got something.
Now it's a.
But there's 2.0 on the second variable.
Okay.
Nice.
Okay. I just want to run one more test case. No, 37 should be. Let's see. 12 should be interesting because it's divisible by a lot of things. Let's see if it gives the optimum solution.
4, 3.
Okay.
It's returning 6,
2. Okay. Because, okay, so when we. So my intuition about finding the optimum solution by starting at half That's obviously not correct. So we kind of need to find a way to just store the values, and as they get arbitrarily close to if they ever equal each other, then we know we found the correct one and we can return it. But so as we start to iterate backwards, we should be getting closer. We should get numbers that are closer and closer to each other. So once we find once we find two numbers that are less close than the closest two than we found, we can return that number. So what we need to do is have just a variable to keep track of that. So So first off, we have a base case where originally we're not going to have anything in our numbers. So if the length is 0, then we can just set it equal to this statement. And then if numbers, okay, this is going to be a little bit messy. So if the absolute value of number 0 minus number 1 is less than the absolute value of our quotient minus our divisor, then we can reset our numbers, or we can reset our numbers variable to this statement again. But if it's not, this needs to be announced. If it's not, then we found one where we start diverging again. So that means that we found so we went through and we found 6, 2, then we found 4, 3, and then we found 2, 6, which would still be represented as 6, 2. But we found one that diverges again, so then we found the optimum solution last time, which means we should return that. So if numbers at 0 minus numbers at 1, if the absolute value of that, which I believe in Python is ABS, is less than, is greater than, because if it's bigger, that means that we found a less optimal solution. If it's greater than q minus divisor, then we can set numbers equal to, I don't know if there's a way to make this into like, I like this statement, but maybe I should have just set it up here and then used it to set all of these. And then else, if it's else, then we can just return numbers, I think. Because we should have caught all the ones that we need, or the best possible solution using this statement. So then once if we ever hit this one, then we should have found the optimal. Okay. I'm ready to try and submit this on the full test case. We'll see how that goes. Wrong answer.
Wait, I see accepted. Oh, okay, never mind.
So for 37, we never find 37 in 1. I think that's probably because 37 is a prime number and I didn't test it on any prime numbers. So I think 11 should probably throw the same error. Yeah, okay. So, okay. I'm gonna walk through the code. So we set numbers, we find our divisor, which in this case will be 5. So then we say, well, divisor is not equal to 0 if area divided by divisor is equal to area integer divided by divisor, which should happen at 1, right?
Yeah.
Oh, I see. So when we hit the first if statement, the third one won't go through. So I think if we take this statement and reverse it, it should only happen if the first one didn't happen. And then so if divisor is equal to 1, this is very brittle code. I don't like it, but it's just to catch that one edge case, I suppose. Okay, so let's double check that it works on like 12. No. Okay.
No.
Okay. I think we can remove this, right? And if if divisor ever hits 1, right, we know we found at least the case, at least the only case that could exist if it's a prime number. So we could set this outside of this larger if statement and just check if the divisor ever hits 1, and then return the divisor in the area. It needs to be larger first, so area, comma, divisor. So that gives us proper. Oh, darn.
What the hell? Just submit it. Try to submit it.
Okay, let's see. I have a feeling like this is not optimal. Whoa. Whoa.
Now it doesn't go through to the second if statement.
It doesn't go through to the second if statement. We should,
because it's divisible by 1, and then it just stops right at line 9, right?
The first time through these statements here, the divisor should be equal to 2 because we start at half. So we take 4, we divide it by 2. It's the same issue, except for it's not the base case of hitting 1. It's the base case of the first number we hit is the actual correct solution. So then when we go through these if statements, we don't ever return the numbers because this is an else statement. So if that's the case, then I don't like doing these. I wish I had a better, more all-encompassing solution. But this should be the last base case. So this is the first. So
If divisor times divisor equals to area.
No, I realized what happened. It was actually your intuition. Your first intuition was correct, because once we hit the output 0 or 4 1, right? It didn't get to the second if statement to return the numbers.
Yep. Now it doesn't go through the else if. Do you want to check discussion? Discuss.
Okay. I think.
See how. Okay.
I think, all right. If we also track the length of the numbers, So if numbers is equal to 0 and divisor is equal to 1, then we hit the correct case because we never added anything to numbers. Okay. 11 works. 12 works.
Nice. I got it.
4 works. Come on. Okay.
If 12. What? Now 1 doesn't work.
I think 1 is the only other number that won't work.
Because 1 is not a prime number. It's neither. It's either.
That is kind of annoying.
So if it's 1, then we just return 1. Nice.
Okay. It actually worked.
It worked. But it's only faster than 5.24% of Python 3.
Yeah, that's sad. But it uses a lot less memory.
Yeah.
I went for the time trade-off, I guess, instead of the space trade-off. I wonder what solution uses that much memory.
Do you want to check the discuss area section to see how other people solve with Python? You can search the tag on the right, Python 3.
Oh, okay.
Yeah.
A simple for loop, which is...
Oh, wow.
Wow. Well.
Wow. 3 lines of code.
Holy snap. Okay. So if it's an int for L in range, int area times half, 0, -1. Okay, so for I in range, so he's iterating backwards like we were. So given that the int, so he's starting at half of the area. Isn't that step? No, this is step. Oh, and this is the end condition. This is 0. So he's starting at half and he's going to 0 and he's minusing 1 every step. Then if the area modulus L is equal to 0.
Man, that's actually so smart.
Yeah, and then area divided by L. Wait. Hold on.
Area divided by L.
Hold on, but wouldn't he run into the same case? Like,
You want to copy his code to try to run it, see if it works.
I have a feeling though that like, wouldn't this run into the same issue where we started iterating and we found the first solution, but it wasn't optimal? Or wait, he divides area by L. What does that do? So
That's it. What was the test case for the first solution it had? You remember?
The test case. I don't remember actually. I think it might have been. I'm not actually sure.
Okay. Let's see. Wow, 97.1.
Why doesn't this run into the first issue where 12 was throwing an error? So like once he hits 6 and 2, right? So
Yeah.
if area modulus 6 equals 0, which it does, so 12 modulus 6 would equal to 0. Then return 12.
6, the return, right? Just to be 2, 6.
Yeah, it would return 2, 6. Why doesn't that happen?
For 3.
What?
So if it's 2, 6, it goes on to the next solution.
Yeah, but how does it do that? Because the only if statement here is area modulus L.
Yeah, 6 2 works. So it's a return at 2 6. How do you go down to the next solution?
Because area times half, it starts at 6, right? And it's going to 0, and it's minusing 1 every time. So the first L should be 6. Area modulus L is equal to 0. Pretty sure, right? Because
yeah.
And then you return area divided by L, which is 2, and L is 6. That is so strange. How does that work?
Yeah.
Maybe this range isn't what I think it is. I'm pretty sure this is where you start. This is where you end, and that's step size.
Let's see. Python 3. Range. Oh. So it's start, stops, and steps.
Yeah, start, stops, and steps. And he had
So John Miner is the applicant, right?
Yeah, I'm the applicant. I did solve said LeetCode problem. And then we also wanted to see why it was so slow, so we looked at the discussion.
I see. Okay, so what different... Yeah, you can actually look, because I'm here to just observe and give you feedback. So I'm not coming here to judge it. I mean, to basically, tell you to do this or do that. I just want to observe the communication between the two.
Okay.
And to be honest, I'm not actually, looking at your solution or your technical readiness. I just want to see how you communicate and talk with each other.
Well, I did just solve it, so we're just about to switch off, I think.
Oh, okay. So you can switch off. Switch.
Zoom, you want to pull up a LeetCode problem?